Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Model Training and Evaluation. Getting the best performance. Imagine you're teaching a new skill, like baking a cake. You can't just expect someone to know how to bake without practice. Right? In AI, model training is exactly that practice session for your AI. It's where your AI learns to do its job. Whether that's recognizing cats in photos or predicting stock prices. Getting the best performance means making sure your AI is really good at its job. Not just okay. As a developer, this is where you orchestrate the learning process for your AI, turning raw data into a smart, functional system. Before we train, what is a model? Think of an AI model as a specialized program or brain we build. But unlike traditional software where you write explicit rules for every scenario, this brain learns its own rules from data. It's like an empty recipe book that's ready to be filled with patterns and knowledge. As a developer, you choose the type of empty brain, the model architecture, e.g., a neural network or a decision tree, and then you'll fill it with knowledge during training. Just like a chef needs good ingredients, your AI model needs good data to learn effectively. This data is the information the model will study. For example, if you're building an AI to recognize cats, your data would be thousands of pictures labeled cat or not cat. We usually split our data into two main parts: training data, what the model learns from, and testing data, what we use to see how well it learned. As a developer, preparing and cleaning this data is a crucial first step. Garbage in, garbage out definitely applies here. Now for the actual training. The process is like showing a child many examples and correcting them. Your AI model looks at a piece of training data, e.g., a cat picture, makes a guess. Is this a cat? Single quote. Compares its guess to the correct answer. Yes, it's a cat. Single quote. And then adjusts its internal workings to get better next time. It repeats this process millions of times over. The adjustments are what we call updating the model's parameters. Think of them as the model's internal knobs that get tuned. As developers, we write the code that manages this iterative learning loop, feeding data and telling the model how to adjust. Once your model has studied all the training data, how do you know if it's actually smart or just memorized the answers? You wouldn't give a student a test that they've already seen, right? That's why model evaluation is key. We use a completely separate set of data, the testing data, or validation data, which the model has never seen before. We then ask the model to make predictions on this new data and see how well it performs. This gives us an honest report card of its real-world ability. From a developer's perspective, this split between training and testing data is fundamental to building reliable AI. To give our AI its report card, we use metrics, fancy terms for different ways to measure performance. The simplest is accuracy, which is just the percentage of times your AI got the correct answer on the test data. If your cat recognition AI identified 95 out of 100 new cat pictures correctly, its accuracy is 95%. Sometimes, other metrics like precision or recall are more important depending on what you're building. E.g., for a medical diagnosis AI, you'd want to be very careful not to miss a disease. As a developer, you'll choose the right metrics based on your project's goals and use libraries to calculate them. Getting the best performance means avoiding two common problems: underfitting and overfitting. 1. Underfitting. **** Your model hasn't learned enough. Like an uncooked meal or a student who didn't study. It's too simple to capture the patterns in the data. 2. Overfitting. ***, your model has memorized the training data perfectly. like a student who just memorized answers without understanding the concepts. It performs great on the training data but fails on new, unseen data. The test data. It's like a burnt meal, perfectly cooked on the outside, but useless. The goal is to find the just right spot where your model understands the underlying patterns and can generalize well to new data. Developers spend a lot of time debugging and adjusting to hit this sweet spot. Achieving best performance isn't a one-shot deal. It's an iterative process. Much like a chef perfecting a recipe, you'll train your model, evaluate it, see if it's underfitting or overfitting, and then adjust hyperparameters. Hyperparameters are settings you control before training starts, e.g., how fast the model learns, how complex it is. You'll then retrain, re-evaluate, and repeat until you're satisfied with its performance on the unseen test data. As a developer, this cycle of experimentation, analysis, and adjustment is a core part of developing high-performing AI applications. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.